Okay, so let's go ahead and do some more of this video with our notes here. Now, I did record this section where on last week from what the lecture was in class, but let me go ahead and do it here on the notes now, and then we'll get into the new section of notes, okay? I'm going to use two colors in a moment, yellow and red, and we're going to use that for our coloring. We're going to color code it, okay? So here's what we talked about in class last week. There are three types of collisions. There's elastic collision, there is inelastic collision, and then there's explosion. Okay, and we actually filled all of this in the previous video for the notes here. Now, elastic collision is when two things are going to hit each other and then they actually bounce off. Kind of like a tennis ball and a racket. Now, what happens is you start with two objects and you end with two objects after the collision. So let's go ahead and do that. I'm going to have object number 1 is going to have a collision with object number 2. Now, after the collision, object number 1 bounced off from object number 2, and they're separated. Okay. Now, inelastic collision is whenever these two things or two or more things are going to hit each other and then they actually stick together. And so you start off with two objects and you end up with one object because they stuck together. Okay? So object number 1 is about to collide with object number 2. And after the collision, object number 1 and 2 are stuck together. And I'm going to obviously make this an obviously larger, bigger size than the beginning. And it's because I have to consider the law of conservation of mass, that the amount of mass I had before needs to equal the amount of mass I have afterwards. Okay? So yellow plus red are about to collide. Once they collide, they stick together and yellow and red are smushed together. Okay? Now the explosion is the opposite of the inelastic collision. Okay? That's the event where we have one object breaks into multiple parts. Okay? And so you start off with one object and you end up with two or more objects. Okay? So let's start off with one object. And again, I'm going to make it a little bit bigger than the ending. So I start off with one object, it explodes, and I end up with two objects. Object number 1 and object number 2. Okay? The amount of mass I have before needs to equal the amount of mass I have afterwards. The amount of momentum I have before must equal the amount of momentum I have afterwards. Now, we did this part, and earlier in the previous video for the notes, I messed up. I apologize on question number 5. A bumper car hits another bumper car. That's an example of an elastic collision. That was a mistake on a previous video. Okay, let's keep going. Again, all of this is already done in the previous video, so please go back and watch that. But I want to come back over here because I want to talk about our examples, our collision examples, but we want to put them into equations now. Okay, so what happens here is when I read these equations, I'm going to need to modify them myself to fit each situation due to the word problem that, we're reading. So again, there are 3. We call it elastic, inelastic, and then we have explosion. Alrighty, and I'm going to go ahead and color code it just like I did on the previous page. Object number 1 is going to collide with object number 2, and I end up with 1 and 2 separate. Over here on elastic, object number 1 is going to collide with object number 2, but after they collide, they get stuck together, and so object 1 and 2 are combined into 1. And then explosion is one object explodes or separates, and now I've got 2 different objects here that are separated. Now let's go ahead and look at the equations that correlate with that. So the first equation right here, I need to make this first equation look like this. So in this case, I have yellow and red before the collision. So here's my yellow and here's my red. They collide and I end up with yellow and red. So not only did I color code the example, but I made my equation match the color-coded example. Okay, let's look at the second one, which we call inelastic collision. On inelastic collision, I start off with 2 objects. Object 1, which is going to be yellow for me, and object number 2, which is going to be red. But after the collision, object 1 and 2 smush together. So in that case, I need to get rid of one of those because I have 2 over here on the right side and I only need 1. So it does not matter which side you get rid of. So I'm going to go ahead and just get rid of that. Now the problem here is that's great that we got rid of it, but in this case, due to the law of conservation of mass, I need to conserve it. Meaning the amount of mass I have before needs to equal the amount of mass I have afterwards. So in this case, mass of object number 1 needs to be brought over, and I need to say plus M1, and they need to be combined together. Now number 1 was yellow, so this was the yellow part, and here is the red part. So yellow and red are mushed together just like this example over here, this color-coded picture. Let's do it on the explosion. Now on the explosion, I start off with, on the left side, only 1 object. So over here, I need to cancel. Which one do we cancel? It does not matter. What does matter is that the mass of the one that I cancel just cannot just disappear. I need to conserve it, and I need to say plus M1. Okay? So M1 is yellow. So here goes my yellow. 2 is red. And after the collision, I end up with yellow and red that are separated. Okay, so that's color coding the equation for the conservation of momentum equation. Now let's do this in practice problems. So hopefully that would help us out a little bit more. All right, so here are the directions it says here. So step 1 is to draw a picture. I suggest to draw the picture. Okay, I don't know how else to do this. I'm trying to simplify it as easy as possible for everyone. Is drawing a picture mandatory to do so that way you can get full points? No, it's not. But if you don't understand how to do it, I'm suggesting to draw the picture. Determine which type of collision occurred, inelastic, elastic, or explosion. Modify your equation so it looks like the picture, and then go ahead and do the math. So let's read this first one. I have a 400 kilogram car, M1. That's the first object, so let's go ahead and call that number 1. And that's a mass, so it's M1. I'm going to go ahead and put a little b, M1b, because this is before the collision. It's traveling east at 30 meters per second, V1b. Now, when it crashes into a parked car that has a mass of, so this is M2b, and they told me that it's parked. And since that's parked, that means that the velocity for number 2b equals 0 because it's not moving at all. Now the two cars crash together in an accident. How fast is the crash moving after the collision? So I said the word crash. They crush together. And because of the crush together, that's telling me right now that that's an inelastic collision that's occurring. So I'm going to go ahead and do the drawing for my collisions. I have object number 1 and object number 2 are going to have an accident, and I'm going to end up with one object afterwards. So this is what I have. Car number 1, car number 2, they collide and crushed into each other. So the equation here is going to be, and let's write out the full equation because that's how I need to start off with, and then I could do my modifications. M1B V1B plus M2B V2B equals M1A V2A plus M2A V2A. Before the collision, after the collision. Now, the before, I have two objects. 1, 2. After the collision, I have 1. So in this case, I need to go ahead and cancel something out. Does not matter which one. The but is that I cannot get rid of the mass. That needs to come over here, and I need to say plus M2A. Okay? Now that's the right equation. Let's go ahead and let's fill in the numbers with it. The mass of the first car was 400, and the velocity of it was 30 meters per second. 30. Plus, the mass of the second car was 200, but the velocity was 0 because it was parked. Now, the mass of object 1, which is 400, look at this right here, plus the mass of object 2, which is 200, times the velocity of it, which is my unknown. That's what I'm looking for. Now, in this case, we can go ahead and do the rest of our math, but we should be ready to go, or, we should be able to do this equation now. You're going to use your algebra skills so that way you can solve for what you need to cancel out and how you're going to do that, okay? But I'm pretty sure that you should be able to do this without any problems. So 400 times 30 comes out to 12,000 plus 200 times 0 is 0 equals 400 plus 200 equals 600 VA. Okay, so let's go ahead and let's keep looking at this one. We are going to add those together, but adding 0 really doesn't do anything. So I'm just going to say 12,000 equals 600 VA. I need to divide by 600, cancel, divide by 600. 12,000 divided by 600 equals VA, or the velocity after the collision, ends up as 20 meters per second. Want to make sure that we all see that they're using directions, east, west, south, north. We know here in physics that when we see directions, they are indicated with positive and negative values. Mathematically, they do not have a numerical value, okay? And so because of that, I don't want to stress us out and worry about those. So when you see directions at this point for this unit, we're just going to ignore it and let's just keep going further. I don't want to confuse anybody. Let's look at the next practice problem. Alrighty, we've got another problem over here. Now for this problem, I got car number 1 who has a mass of 300 kilograms, M1B, okay, and it's traveling east 10 meters per second, V1B. Now car number 2 who has a mass of 200 kilograms, M2B, is moving east V2B 6 meters per second. Car 1 crashes into car 2 and they stick together. So that is an indication of an inelastic collision. What is the speed of the new mass? Question mark, velocity after the collision. So let's go ahead and draw that out. Car number 1 is driving and car number 2 is driving. They have a collision and they become smushed together. So this is what my equation looks like. Let's go ahead and let's fill in the actual equation and modify it to look like this. So M1B V1B plus M2B V2B collides. And we have M1A V2A plus M2, that should be a 1, that should be a V1A, M2A V2A. Okay, now on before the collision, I have two objects and I have two objects over here. 1, 2. After the collision, I only have one. So in that case, I need to go ahead and modify this. It does not matter which one you get rid of. So I'm just going to get rid of one. But I cannot get rid of the mass. That needs to be brought over. So plus M1A. Okay. Now, I'm going to go ahead and fill in my numbers to match this equation. The mass of object number 1 is 300. The velocity is 10. The mass of object number 2 is 200. The velocity is 6. Equals the mass of 1 and 2 added together. So that would be 300 plus 200 times the VA. And that's what we're looking for. So now use your algebra skills, all right? So that way you can go ahead and solve for this. 3,000 plus 1,200 equals 500 VA. I'm going to go ahead and get the 1,200 and plus the 3,000, add those two together. I know I said it in class, and I'm going to make sure I say it again, that we need to use the order of operations. Please excuse my dear Aunt Sally. So 3,000 plus 1,200 is going to be 4,200 equals 500 VA. I need to solve for VA. Those two are being multiplied. So let's divide. Okay, divide by 500. After the collision, the velocity of both of them combined is going to be 8.4 meters per second. I think this is probably a new concept for some of us. We're really unsure. We might feel iffy. Let's continue to practice, okay? We're not going to get better until we just practice on them over and over. This one, I did this one in class, so I hope you saw it. I hope you paid attention. If you didn't, I'm going to do it again here just to help you out. If you did, then fast forward it because you've already saw this information. There's a monkey who has a mass of 30 kilograms, so M1B. He's running east at 7 meters per second, V1B. Bob, who has a mass of M2B, 75, is standing still. Standing still is a value, which is V2B equals 0. It's not paying attention. Now, the monkey runs and latches onto the man. Okay, so that's a clue that this is an inelastic collision, knocking him over. What is the velocity of the monkey and the man together after the collision? So let's go ahead and draw this out. I have the monkey and I have the man. They collide and they become one object, the monkey man, together. Now let's go ahead and fill in our equation. I'm going to fill it all in. M1B V1B plus M2B V2B collides. and we have M1A V1A plus M2A V2A. And I need to make this equation look like that. So before the collision, I have two objects. 1, 2. After the collision, I only have one. So in that case, let's go ahead and let's cancel something out. It does not matter which side. So I'm going to cancel this out, but I must continue to conserve the mass. So I'm going to say plus M1A. Alrighty. So now that we've got our modified equation, I'm going to fill in the blanks. The mass of the monkey was 30. His velocity was 7. The mass of Bob was 75. His velocity is 0 because he's standing still. They collide. Now the mass of the monkey is 30 plus the mass of Bob of 75. Multiply it by the velocity after the collision. Let's go ahead and let's do this. 30 times 7 equals 210. Plus 75 times 0 is 0. Yields, let's don't forget that those two are going to be multiplied here together. Okay, 30 plus 75 equals 105. 7, 8, 9, 10, 105. VA. Alrighty, let's keep going. 210 plus 0 is 210 equals 105 VA. I'm looking for the velocity, so if I divide 105 on this side, that cancels. Divide 105 on this side. The velocity after the collision between Bob and the monkey comes out to 210 divided by 105 equals 2 meters per second. Box that in. And there goes your answer. Hopefully we're getting a little bit more comfortable with this. Alrighty. This one right here, again, I did this one in class, but I'm going to go ahead and do it again just in case. If you don't want to see it, please fast forward through this part of the video. But there's a tennis racket. M1B before the collision is moving east at 12 meters per second, V1B. Now there's a tennis ball, M2B, who is moving 22 meters per second east, V2B. After the collision, the racket begins to move. So who is the racket? The racket is 1. So M1A, 6 meters per second. And I wrote an M, but it should be a V for velocity. I'm going to come over here and white that out. V1A. How fast is the ball moving? The ball is number 2, so question mark V2A. Now, between a racket and a tennis ball, they're not going to stick together, so this is going to be elastic collision. Meaning, I'm going to start off with object number 1 plus object number 2. They collide and they end up with object number 1 and number 2 separated. Now that is our regular old equation right here written out with no modifications. So let's go ahead and let's write that in. M1B V1B plus M2B V2B collides. And now we have M1A V1A plus M2A V2A. So there's the full written out equation that correlates with our drawing. Object number 1 plus object number 2 collides and they end up with object 1 and 2 separated. I'm going to go ahead and fill in those blanks now. 3 times 12 plus 0.06 times 22 equals, I'm not changing any mass and adding those, they're still going to be separate. 3 and 1 is the racket. So 1 here is 6. 3 times 6 plus the ball is 0.06 times V2A. And that's my unknown. let's go ahead and let's fill in and finish our multiplication or our order of operation. I'm going to multiply 3 times 12, which is 36, plus 0.06 times 22, which is 1.32, equals, right, we want to make sure, 3 times 6 is 18, plus 0.06 V2A. We're not done yet. Now let's go ahead and do our addition. 36 plus 1.32 is going to be 37.32 equals 18 plus 0.06 V2A. Those two numbers cannot be added together. Some students want to add them together. But go back and think about math class when you were doing factoring. When you were factoring out those numbers, let's just say you had 18, then you had 3A, 3B, and 3AB. Could you add the 18 plus those 3's? No, you can't, because you had an 18 by itself, a 3A by itself, a 3B by itself, and a 3AB. When you factor those, you were unable to combine them together because they were different. Same thing here. This is just a number, and then this is a number with a variable with it. It's combined, and I cannot add a number with a number variable. Okay? So in this step, the next thing to do is, because 18 is being added, let's subtract 18 and cancel out. Subtract 18. So 37.32 subtract 18 comes out to 19.32 equals 0.06 V2A. I'm going to carry it over here. Now, we're not done yet because I need to divide. So 19.32 equals 0.06 V2A. Divide by 0.06, cancel, divide by 0.06. So 19.32 divided by 0.06 comes out to the velocity of that ball after the collision is 322 meters per second. There we go. Not too bad. So we did all 4 practice problems here on the video notes. All right. Hopefully that would help you out. At least try it and then go back and check your answer. See if you got the same thing as me. Determine the velocity of the second ball after the collision. Okay, so here's ball 1, ball 2. After the collision, ball 1, ball 2. And those two lines are separated. So that's showing me that they're not sticking together. We're going to call this collision elastic. So here's the equation written out. And I'm going to go ahead and fill in this equation because it's 100% correct. I do not need to modify it. So in this case, before the collision, the mass of the first ball is 4. The velocity is 10. The mass of the second ball is 3. The velocity of the second ball is 12. After the collision now, the mass of the first ball, which is the same, is 4, but the velocity is 2. And the mass of the second ball has the same mass, which is 3. But the velocity, V2A, I do not know. Now let's go ahead and do our math. That's going to be 40. Excuse me. 36. 8 plus 3V2A. I'm going to go ahead and get the 36, add it to the 40, and I end up with 76 over here equals 8 plus 3V2A. Subtract 8, cancel, subtract 8. I end up with 68 equals 3V2A. Now I'm going to divide by 3, cancel out, divide this side by 3. The velocity of that second ball after the collision is 22.67 meters per second. Alrighty, let's keep going. Now, At this point, we have completed the first section of our notes. So I'm going to draw a line right here. And then, I don't know, but I hope this helps some of you out. This is going to be part 1. And below the line is part 2. And the reason why I'm telling you this is because we are going to have 2 different quizzes. Everything above the line is part 1, and that will be quiz this Friday. Everything below the line is going to be part 2, and that's going to be a separate quiz, okay? But we need to go ahead and work on our notes for this. So let's get those notes done and completed. So earlier we utilized Newton's 3 laws of motion, and in those 3 laws of motion we were able to analyze the motion of objects. So we're kind of pulling back some of the stuff that we've talked about before, okay? Force and mass information were used to determine the acceleration of an object. And acceleration information was later used to determine the information about the velocity or displacement. We're talking about kinematics of that object during a certain time period. Now, using that information from Newton's laws serves as a useful model for analyzing motion and making predictions about the state of the object's motion. Now in this part of the unit, because remember it's 2 units combined into 1, an entirely different model will be used to analyze the motion of objects. Motion will be approached from the perspective of what we call work and energy. Alrighty? Work and energy. First word. So let's go ahead and start off with the first topic, work. Now, what is work? Now, I'm sure some of you, if I was to ask you, hey, what work do you have going on, or what is your work? Many of us would probably think job, or I've got homework to do, or I got to go home so I can do chores. That's my work I got to do for today. But